Okay, today we're going to be using quadratic equations to solve some various word problem setups. And hopefully by the end of it, you feel pretty comfortable with what's going on. Let's look at this first one. Rocket A and Rocket B are launched into the air. The heights of the rockets are given by the following equations. The height of Rocket A is negative 16t squared plus 64t, and the height of Rocket B is negative 16t squared plus 50t. When does Rocket A hit the ground? And, so when we look at a word problem, we want to know what is it asking us for. So what is it asking when it says, when does Rocket A hit the ground? How does that relate to this height of the rocket at various times? Well, the when is asking us, what is t going to equal? So we're going to solve to find what t is. When it hits the ground, that is when the height is 0. So we're looking for where is the height going to be equal to 0, and so we're solving this equation. Go ahead and solve this equation on your own. And hopefully you were able to see that you can factor this. We always want to start by trying to factor, and I see they have a common factor of t and a common factor of negative 16. Whenever there's a negative in front, we can factor it out. So I'm going to factor out the negative 16t times t minus 4 equals 0. So we factored this, and now it's just two things multiplying to make 0. And so the 2 times it's equal to 0 are t equals 0 and t equals 4. Those will make this equal to 0. And you could have used the quadratic formula to solve this as well. It just would have taken a lot longer. So which one of these times is it hitting the ground? Well, if a rocket launches up into the air, it's probably going to start at the ground, and that will be at time equals 0. And so the other time is going to be when it hits the ground. It goes up, it comes down, boom, t equals 4. So after 4 seconds, I guess I should have said in here that this is measured in seconds and feet. So this is feet and seconds. So the heights in feet after t seconds. Okay, how about Rocket B? When does Rocket B hit the ground? Here you're going to need to use a calculator and round it to 3 decimal places. So, well, let's see. When does it hit the ground? Again, this should mean when is this equal to 0? So when is the height 0? That's where it hits the ground, is when the height is 0. And when is asking us what is t going to equal? So what t will make this equal to 0? And let's see. Here we've got t. I can factor out a common factor again. I can say they both have a t. They also both have a 2. So I'm going to factor out negative 2. And this will be 8t minus 25 equals 0. And so I can see that this will hit the ground when time is 0. And when time equals, it's hard for me to just look at this and see what t makes this 0. Here I could just see 4 minus 4 was 0, but here it's 8 times something minus 25 equals 0. So I'm actually going to set this up on the side and say 8t minus 25. Where is that equal to 0? And I'm going to add 25 and divide by 8. And it asks us to use a calculator to round to 3 decimal places. So 25 divided by 8 is 3.125 seconds. So that is the correct height. That's the correct amount of time where the ball hits the ground. Again, this is where it started on the ground. So the rocket started on the ground, went up into the air, hit the ground. So it's not hitting the ground here, it's starting on the ground. Then it goes up in the air. Boom. Okay. When is Rocket A 48 feet high? So again, this is looking for what t is equal to. When is it 48 feet high? Well, we need to set this equation instead of when does it hit the ground, that's when the height will be 0. Now we want the height to equal 48. So what's the time that will make the height equal to 48? And so we're solving this equation. Go ahead and solve it yourself. And again, we should start by trying to factor. So negative 16t squared, we need to make it equal to 0. So I'm going to subtract 48 on both sides of the equation. So minus 48, minus 48. And so we get minus 48 equals 0. And this time they don't all have a t in common, but they all do have a 16 in common. So I'm going to factor out the negative 16. Whenever there's a leading negative, we want to factor that out. And we get t squared. Negative 16 times t squared is this. Negative 16 times negative 4t gives us positive 64t, and negative 16 times positive 3 gives us negative 48, and this needs to equal 0. This looks factorable, and I'm going to try to factor it. So t, what multiplies to make 3, that adds to be negative 4, and that's negative 3 and negative 1. Negative 3 times negative 1 is positive 3. Negative 3 plus negative 1 is negative 4. And so now I can see t equals 1 or t equals 3. So there's actually 2 different answers for when the rocket is at 48 feet high. Either one of these, it will make it 48 feet high. Okay. How about this? When is rocket B 48 feet high? So again, what's the setup? Well, when is looking for what the time is going to equal, and it wants to be 48 feet high, so we need to say the height needs to be 48. So this is a formula for the height, negative 16t squared plus 50t. When is this going to equal 48, just like before? But this time when we make it equal to 0, when it's equal to 0, now they don't all have a 16 in common. It looks like they all have a 2 in common. So I'm going to factor out a 2 and get 8t squared minus 25t plus 24. But I don't see anything else in common. Negative 2 will never equal 0. So it becomes like, when is this equal to 0? And that's a little bit simpler than when is this one equal to 0. So that's nice. It got a little easier. So I don't see how to factor this right away. So I'm going to go ahead and do the discriminant. I'm going to do b squared minus 4ac just to see, is it possible to factor? So we're going to do b squared, so negative 25 squared minus 4 times 8 times 24. And that is a negative number. Because it is a negative number, I know that rocket B will never be 48 feet high because the square root of a negative is an imaginary number. So when I try to do the quadratic formula, I'll get an imaginary answer out, and that tells me that the rocket will never be 48 feet high. Try this one on your own. When is rocket A 100 feet high? And hopefully you got on this one that, let's see, so the height of rocket A is negative 16t squared plus 64t. When is this equal to 100? Oops, 100. And so you should start by making it equal to 0. These all have a common factor of 4, so I'm going to factor out a negative 4. This is going to be 4t squared minus 16t plus 25. And now it's a smaller numbers to do in the quadratic formula when we do it. This looks too hard to do. I could do the quadratic formula, or I'm going to start by checking the discriminant. B squared minus 4ac. This is, I believe, 256 minus 400 is negative 144. And again, because it is a negative number, this will never reach 100 feet high. So it'll never reach 100 feet high. And we can tell that really easily by using the discriminant. And we could have actually done the discriminant on this one too. It just would have been bigger numbers, and I would have needed to use a calculator instead of just doing it by hand. Okay, let's take a look at some different types of problems that we may or may not have seen before. What numbers fulfill the following property? When the number is squared and then increased by 10, it will be 46. And what we always want to do now that we have taken Algebra 1, and as we continue on into higher math, we want to try to come up with when things need to be true, we want to come up with an equation that matches it. So what numbers, when the number is squared, then increased by 10, it will be 46. So what number? We're looking for this number. So if there is something we are looking for that we don't know, we usually assign it a variable like x or n. It doesn't super matter, but that number is going to be what we're trying to find, right? So we're going to assign the number a variable and then set up an equation. So what equation would match this now that we've given this number a variable? What equation would match this? Well, it says x is being squared, so x squared, and then it gets increased by 10, and then it needs to be 46 after we square it and add by 10. So what does it will be 46 means? Well, that means it needs to equal 46. So this is an equation we need to solve, and we can solve it by getting the quadratic we can make it equal to 0. There are other ways to do it as well. And factoring. This is a difference of 2 squares, so x minus 6 times x plus 6 equals 0. And so the answers are x equals 6 and x equals negative 6. Now, when we're doing a word problem, we always want to go back and make sure we've answered the question. What numbers fulfill the property? When the number is squared and increased by 10, it will be 46. Are these the numbers that when they are squared and then increased by 10, they will give you 46? Yeah, 6 squared is 36, and increased by 10, it will be 46. Negative 6 also works, because negative 6 squared is 36, and when you increase it by 10, that will be 46. Here's a slightly harder one. 2 consecutive even integers have a product of 24. What could the values of these integers be? Okay, so there's a lot going on here. We need to know what integers are, and we've talked some about this. Integers are, it could be positive or negative whole numbers, so like -3, 7, 52, all of these are there. But it also says they need to be even integers, so that means ones that end in 2, 4, 6, 8, or 0, so not 3 or 7. So they need to be even integers, and they need to have a product of 24. So you might think, like, we set up an equation. So product means they need to multiply. So multiply to make 24. And you might think we need 2 variables here, maybe like x times y equals 24. But this isn't, we can do better than this, because it says they are 2 consecutive. That means they come in a row. So like the even integers go 0, 2, 4, 6, 8, 10, 12, 14. Consecutive means they come right after the other. So 4 and 6 are consecutive even integers. 12 and 14 are consecutive even integers. But like 6 and 12 are not, because they're not next to each other. So since they are consecutive even integers, it said, hint, call the smaller one n. So one of the integers is going to be n, and that needs to multiply times the other integer. And if n is the smaller one, what do we know about the larger one? Because they are consecutive and even, it means they're spaced apart by 2, the next one must be n plus 2. So this is kind of powerful and difficult if English, especially if English is not your first language. Reading this and getting all the information out of it is important. 2 consecutive even integers, every single word is important, have a product of 24. So for them to be consecutive and even, it means the next one after it has to be 2 above what it is. So these have to multiply to make 24. Okay? Go ahead and solve this on your own. Well, we know we need to make it equal to 0, and we should try multiplying this out. So n squared plus 2n, we need to subtract 24 on both sides to make it equal to 0. So minus 24 equals 0, and now it's in a nice quadratic form. We talked earlier about changing forms of quadratics, and one of the nice things about general form, we said, is that it lets us use the quadratic formula. So if it's not in general form, we need to get it into general form so we can use the quadratic formula, or factor. So we can factor this. It's what multiplies to make negative 24. That adds to be 2, and that is 6 and negative 4. So n plus 6 and n minus 4 equals 0. So n could be negative 6 or n equals 4. Now, we always want to go back and make sure we've answered the question. 2 consecutive even integers have a product of 24. Are these the 2 things that when we multiply them have a product of 24? No. Remember, we called the smaller one n. So one possibility is if n is negative 6, this is the smaller one, then the bigger one is 2 above it, because it's the next even integer. So negative 6 and negative 4 work. That's a consecutive even integer that when you multiply them together give you 24. So negative 6 and negative 4 is one answer. Or the other possible, remember, n was the smaller one, so the smaller one could be positive 4, and then the bigger one would be what? Well, the next consecutive integer after 4 is 6. And these also multiply together to give 24. So 4 and 6, or -6 and -4, are the two possible pairs of integers that they're even, they're consecutive, they come one right after the other, 4, then the next one is 6, -6, the next one up is -4, and they multiply to make 24. Okay. A square is altered. Whenever there's a geometry one, I start by drawing a picture. There's a square. And I try to label things. I know that this is a right angle in a square, and I know that all the sides are the same. And I'm going to use a variable here because I don't know what that length is. So a square is altered so that its length, we'll call this the length, is increased by 6. So what's the new length going to be? Well, if the old length was x, the new length is going to be x plus 6. But its width, I'll call this the width, is decreased by 2. So if the old width was x and we altered it means changed. So it's changed. So what's the new width? Well, if the old width was x, the new width will be x minus 2 because it was decreased by 2. What shape does this now make? Well, instead of being a square, it's now a rectangle. The length got much longer and the width got shorter, but it's all based on this original one of x and x plus 2. So the area of the new rectangle is 9. What has to be true? What equation would say the area of the new rectangle is 9? So the area of a rectangle is length times width, and so the length times the width needs to be 9, okay? And now it asks us, what is the area of the original square? Well, how the hell are we supposed to get from here to what the area of the original square is? Well, the trick here, of course, is that we find what x is because that's what the length of the original square was, and we'll be able to find the area of the original square if we can just find x. So go ahead and solve this. Recognize that you need to change it to general form first. So hopefully you started by changing this to general form. X times x squared, x is x squared. X times -2 is -2x. 6 times x is 6x. 6 times -2 is -12. And the other thing we need in general form is we don't want it equal to 9. We want to subtract it and make it equal to 0. And now we can combine like terms. So we've got x squared. This is plus 4x. This is minus 21 equals 0. And let's try to factor it before we use the quadratic formula. So what multiplies to make 21, so 7 and 3, and that can give us 4. So plus 7 and minus 3, because that way it multiplies to make -21 and adds to be positive 4. So x is -7 or x is positive 3. What is x again? What does x represent in this problem? Is that the answer? No, x is the length of the square. Is that what they're asking for? No, they're asking for the area of the original square. So could the length of a square be -7? Now, it doesn't make any sense for the length of a square to be -7. This is called extraneous because even though it's solved correctly, it doesn't make any sense in the problem. How about x is 3? Could the length of the original square be 3? Sure, it could. And so this had to be the length of the square. And so what was the area of the square? Well, the area is the length times the width, which is x squared. So 3 squared is 9, and that was the area of the original square, which is kind of crazy that both the originals, even though they completely changed the length and the width, this new rectangle had an area of 9, and the original square also had an area of 9. That surprised me. I did not expect that to go that way. Okay. The revenue brought in by selling a product at a price P is given by R of P equals 10P minus P squared. So this is a formula that tells us the revenue for different prices. Okay, what would the revenue be if the price was 5? So the price is 5, so we're going to put in 5 for the price, and it wants to know what the revenue needs to be. Well, if we just put in 5, it'll tell us the revenue. So the revenue when the price is 5, we write it as R of 5. When P is 5, we put in 5 there, is equal to 10 times 5 minus 5 squared. 10 times 5 is 50. 5 squared is 25, 50 minus 25 is 25, and so the revenue would be 25. What prices would make the revenue 7? Use a calculator and round to the nearest penny. What prices would make, so we're looking for what P is going to be equal to. So now we need to find what P will make revenue equal to 7. So this revenue needs to equal 7. So 10P minus P squared needs to equal 7, and we need to solve for P. The first step we need to do is rewrite this in standard form. How should that be written? We always want the P to go first. So negative P squared plus 10P. We need to move the 7 over. So subtract 7 on both sides. Minus 7 equals 0. And let's see. I don't see how to factor it right away. Let's do the discriminant and see if we can do the quadratic formula on this, if there will be any solution. So B squared minus 4, A is negative 1, C is negative 7. So 100, negative 4 times negative 1 is positive 4. Positive 4 times negative 7 is negative 28. 3 negatives multiply to make a negative. And this is 72. So this is a positive number. It will have 2 solutions, in fact, and we can do the quadratic formula. So the quadratic formula will be negative b plus or minus the square root of, we already did b squared minus 4ac, 72. We don't need to redo it. All over 2a, and a was negative 1, so 2 times negative 1. It said to do, normally I would simplify the square root of 72 because 4 goes into it, and I would split it up, whatever. But it said to use a calculator, so we're going to use a calculator to just evaluate this. So what are the 2 values that we get? Well, one of them is negative 10 plus the square root of 72 divided by 2 times negative 1 is negative 2. So one is 0.76. It said round to the nearest penny. So 0.76 is one answer. The other one is the minus. We need to do both the plus and the minus. Now notice I can't do this in a calculator. You want to be really careful. If you type in something like this, this will give me the wrong answer because only the 72 will get divided by negative 2. It won't divide the whole thing. So you'll notice I added them and then divided by 2, because if I hadn't, it would give me the wrong answer. Another thing I could have done is done like a fraction bar or something. But you do want to be a little careful depending on what kind of calculator you're using. Like this comes back out to the right answer. Not to like do it all written out sideways like this and have it only divide. I also could have done a parentheses. So this is another way I could have written it correctly. The whole top divided by negative 2, and now it's going to come out right again. So you got to be a little careful about how you enter that in. Okay, so what's the other one? The other one is minus. So negative 10 plus this and negative 10 minus this. The other thing is 9.24. This is the 2 answers rounded to the nearest penny. Pennies are 2 decimal places in. And so here we had 0.24 and a 2 came after, so we rounded down. Here we had 0.75 and a 7 came after, so we needed to round that up to 76. Okay, a right triangle has one leg with a length of 4. Guys, as soon as I see geometry, I'm drawing a picture. There's a right triangle that has one leg with a length of 4. And a hypotenuse of 5. So that's the side that's across from the right angle. What is the length of the other leg? So we're looking for this, and if we don't know it, I'm going to call it x. So how can we solve this? Well, we can use our geometry, and hopefully we know that in a right triangle only, a squared plus b squared is equal to c squared. We do need to know that. And we can simplify some. 16 plus x squared equals 25. We could, when there's just an x squared, you can just subtract 16 and take the square root of both sides, but we could do it by factoring, by making it equal to 0. That will always work also. So minus 25, minus 25. We want to put the x squared first, so we usually put x squared. 16 minus 25 is negative 9. And this will factor to x minus 3 times x plus 3 equals 0. So x could be 3 or x could be negative 3. Now, the length of a triangle is never negative, so this is an extraneous solution. The only answer was x equals 3. A right triangle has a longer side. Oh, so we're going to draw it. Okay. A right triangle has a longer side that is 17 inches longer than its shortest side, and a hypotenuse that is 18 inches longer than its shortest side. So I'm going to call the shortest side x. So the shortest side I'm going to call x, and the reason I chose the shortest side as x is because it gave me a formula for how to find the other sides. The longer side is 17 inches longer than the shortest side. So how do I find that? Well, that's x plus 17. It'll be 17 inches longer. And the hypotenuse is 18 inches longer than its shortest side. The shortest side is x, and so the hypotenuse is 18 inches longer than that. What is the perimeter of the triangle? So the perimeter of the triangle is we need to add these up. And I can add these all up, and I can get x plus x plus x is 3x. 18 plus 17 is 35. But we can do better. We can actually find what x is. We can find what x is by having a relationship between these sides. What is the correct relationship between these sides? Well, again, it's a right triangle. And so we can use the Pythagorean theorem. A squared plus, I'm going to make sure this is in parentheses, b squared equals c squared. And I can square it. This one's going to stay alone. When we square a binomial, we need to use the squaring a binomial trick, or we can actually multiply out x plus 17 times x plus 17. But you got to make sure you distribute if you're doing this, right? So when you square a binomial, you square the first one. We multiply these two together and double it. X times 17 is 17x. Doubled is 34x. And then we have to square the last one. Ooh, what is this? Is that 289? I don't remember what 17 squared is. I think it is. 17 squared is 289 equals, we have to square the first one, multiply these two together and double it. So that's 18 times x is 18x, doubled is 36x. And we have to square the last one, 18 times 18. And I believe it's like 324 or something, but that might not be right. 324, good. Okay, this is a quadratic, and we always want to make it equal to 0. So we're going to subtract x squared. We're going to subtract 36x. And I'm lining them up with ones that they can combine with, and subtract 324. Here I've got x squared plus x squared is 2x squared, minus 1x squared is just x squared. Or another way of thinking about it is that these cancel out, so there's just 1x squared left over. 34x minus 36x is negative 2x. I almost wrote negative 32x. And then 289 minus 324, 289 minus 324 is negative 35, and that's equal to 0. And we can solve from there. What is x going to equal? So x, I need two things that multiply to make negative 35, that add to be 2. So 5 times 7 seems like that'll be 2. The bigger one needs to be negative. That way it adds to be a negative. So x is 7 or x is negative 5. One of these is extraneous. X equals negative 5 doesn't work because you can't have a side of a triangle that's a negative length. Sides of triangles are only positive lengths, and so x is 7. So this length was 7. This length was 7 plus 17 is 24, and this length is 7 plus 18 is 25. Notice that if I do a squared plus b squared, 7 squared plus 24 squared, it will equal 25 squared. A squared plus b squared equals c squared. And since x was 7, 3 times 7 is 21 plus 35. This is the perimeter of the triangle is 56. Or I could have plugged in here and then added these up. So 31 plus 25 is 56. All right, guys, hopefully you're feeling better about these. And after having some practice, you're feeling better and better. And the homework has very similar problems for you to practice.